In this series of videos, I will discuss some of the subjects that students often struggle with in math. In this particular video, I will discuss some operations with positive and negative numbers. This slide shows the topics that I will discuss in this video, as well as the numbers of the slides, so that you can fast forward to the topics that interest you. The slide numbers are located in the lower right-hand corners of the slides. Positive numbers tell you how far above zero you are, and negative numbers tell you how far below zero you are. For example, the thermometer on the left here is showing a temperature of 2 degrees below zero, and so we can say that it is showing a temperature of negative 2 degrees. The thermometer on the right is showing a temperature of 8 degrees above zero, and so we can say that it is showing a temperature of positive 8 degrees. To say that a number is positive, we can put a plus sign in front of the number, but we do not have to do this. Here are some more examples that illustrate what the positive and negative signs in front of numbers mean. Note that the dot labeled negative 3.5 is 3.5 below 0. The dot labeled negative 1 3/4 is 1 3/4 spaces below 0. And the dot labeled positive 2 1/4 is 2 1/4 spaces above 0. The absolute value of a number is defined as the number's distance from 0. Since distance is never negative, this means that the absolute value of a number will never be negative. For instance, the absolute value of negative 3 is 3 because negative 3 is 3 spaces from 0, and the absolute value of 4 is 4 because 4 is 4 spaces away from 0. Now, let's talk about how we can add two signed numbers. To add two numbers that have the same sign, you can add their absolute values and keep the same sign. For example, 2 plus 4 is, of course, equal to 6, and you can see why this works by starting at 2 on the number line, and then, since we want to add a positive 4, moving 4 spaces to the right. Note that you end up at 6. To add negative 1 plus negative 3, you can start by noting that the absolute value of negative 1 is 1, the absolute value of negative 3 is 3, and 1 plus 3 is equal to 4. Then, since both of the signs were negative, we can say that negative 1 plus negative 3 is equal to negative 4. To see why this works, note that in order to add these two numbers, we can start at negative 1 on the number line, and then, since we want to add a negative 3, move 3 spaces to the left. Since we end up at negative 4, we can say that negative 1 plus negative 3 is equal to negative 4. Also, a lot of students don't understand what the parentheses are saying in this problem. In this problem, and in the problems that use parentheses on slides 7 through 13, the parentheses are not doing anything except making the problem easier to read. I could erase the parentheses on any of the problems in this first set of slides, and the problems would say exactly the same thing. To add two numbers that have different signs, you can subtract the absolute values of the numbers and then keep the sign of the number with the larger absolute value. For example, to add 2 plus negative 5, you could begin by noting that the absolute value of 2 is 2, the absolute value of negative 5 is 5, and 5 minus 2 is equal to 3. Then, since 5 is larger than 2, and since the 5 has a negative sign, we will make the answer negative. To see why this works, note that this problem is telling us to start at the 2 and then move 5 spaces to the left. Note that we end up at negative 3, which, of course, agrees with the answer we got earlier. To add negative 3 plus 4, I can subtract 4 minus 3, and then, since 4 is larger than 3, and since the 4 is positive, keep the answer positive. This tells us that negative 3 plus 4 is equal to positive 1. To see why this works for this example, you can note that this problem is telling you to start at the negative 3, and then move 4 spaces to the right. Note that, when you do this, you do end up at positive 1. To subtract two signed numbers, you can change the subtraction sign to addition, change the sign of the next number, and then follow your rules for addition. For instance, to subtract -5 minus -1, we can change the subtraction sign to addition and then change the -1 to a +1. Since we can use the concepts we discussed in the last slide to say that -5 plus +1 is equal to -4, this tells us that -5 minus -1 is equal to -4. To see why this works for this example, note that we are told to start at -5 on the number line. Then we see a subtraction sign, which should tell us to move to the left. But before we see a number that tells us how many spaces we are supposed to move to the left, we see a negative sign that tells us to reverse our direction and move to the right. So, to work this problem, we need to start at -5 and move one space to the right. Note that this is exactly what we should do if we want to add -5 plus +1. To subtract -3 minus 2, we can change the subtraction sign to addition and then, since we were told to subtract a +2, change the 2 to a -2. We can use the concepts from slide 6 to say that -3 plus -2 is equal to -5, and so this tells us that -3 minus 2 is equal to -5. To see why this rule works for this example, note that this example tells us to start at -3 and then move 2 units to the left. Also note that this is exactly what we would do if we wanted to add -3 plus -2. To multiply two numbers that have different signs, you can multiply the absolute values of the numbers and then make the answer negative. For example, if we want to multiply -6 times 3, we can start by noting that 6 times 3 is 18, and then, since the two numbers have different signs, make the answer negative. To see why this rule works for this example, you can note that this problem is telling us to add -6 to itself 3 times. Note that the picture here shows 3 groups with 6 negatives in each of them, and that there are a total of 18 negatives in this picture. As another example, let's look at 5 multiplied by -2. 5 times 2 is 10, and then, since we have two different signs, we must make our answer negative. To see why this rule works for this example, note that this problem wants us to add -2 to itself 5 times. Also note that this picture shows 5 groups with 2 negatives in each group, and that there is a total of 10 negatives in the picture. To multiply two numbers with the same sign, you can multiply the absolute values of the numbers and then make the answer positive. This tells us that 7 times 4 is, of course, positive 28. To see why this rule works for this example, you can note that you want to add 4 to itself 7 times, or, as the picture shows here, 7 to itself 4 times. Note that the picture here shows a total of 28 positives. To multiply -3 by -2, we will start by noting that 3 times 2 is 6, and then, since we are multiplying two numbers with the same sign, keep the answer positive. This tells us that -3 times -2 is equal to positive 6. The easiest way to understand why this rule works is to look at the patterns you see here. The rules for dividing two signed numbers are almost identical to the rules for multiplying two signed numbers. To divide two numbers that have different signs, you can divide their absolute values and then make the answer negative. For example, to divide -12 by 3, you can start by noting that 12 divided by 3 is equal to 4, and then, since the two signs are different, make the answer negative. Therefore, -12 divided by 3 is equal to -4. To see why this rule works, you can note that this question is telling us to ask ourselves, what multiplied by 3 gives me -12? Or you can note that we can split 12 negatives up into 3 equal groups with 4 negatives in each group, as shown here. To divide 24 by -6, we can start by noting that 24 divided by 6 is equal to 4, and then, since we are dividing two numbers with opposite signs, make our answer negative. To see why this rule works for this example, you can note that this question is telling us to ask ourselves, what multiplied by negative 6 gives me 24. To divide two numbers with the same sign, you can divide their absolute values and make the answer positive. So, for example, 56 divided by 8 is equal to 7 because, of course, you can split the 56 positives up into 7 equal groups with 8 positives in each group, or 8 equal groups with 7 positives in each group. To divide negative 14 by negative 7, you can start by noting that 14 divided by 7 is equal to 2, and then, since negative 14 and negative 7 have the same sign, keep the answer positive. To see why this rule works for this example, you can note that this question tells us to ask ourselves, what multiplied by negative 7 gives me negative 14? Or you can note that we can split negative 14 up into 2 equal groups with 7 negatives in each group. In the remainder of the slides in this video, I will discuss what happens when we have several operations involved. When we have 2 or more operations involved in a problem, we must follow a process called the order of operations. The order of operations tells us that, when we are asked to simplify a problem that involves more than one operation, we should start by simplifying everything inside any parentheses. Next, we can move on to exponents. After that, we can multiply and divide in order from left to right. Finally, we add and subtract in order from left to right. Many people like to use the phrase, "Please excuse my dear Aunt Sally," to remember this. Now, let's look at the example you see here. Note that there are no parentheses or exponents in this example, and so we can skip those steps. We do, however, have some multiplication. So, in order to find the correct answer to negative 5 plus 2 times 7, we must start by multiplying 2 times 7. And now, since negative 5 plus 14 is equal to 9, we can say that the final answer to this question is 9. In this example, the expression inside the parentheses has already been simplified as much as it can be simplified, and there are no exponents. Therefore, we will skip those steps again. Note that the order of operations says that we must multiply and divide in order from left to right. Also note that, in the example you see here, the division comes before the multiplication as you read the problem from left to right. Therefore, we must start by dividing negative 18 by negative 3. And now, since 6 times 2 is equal to 12, we can say that the final answer to this question is 12. Here's another example. We don't have any parentheses, exponents, multiplication, or division, and so we can skip all of those steps. We must add and subtract in order from left to right. So, since the subtraction comes first as you read the problem from left to right, we must start by subtracting 15 minus 8. However, if we put parentheses in the problem, as you see here, we must start by adding the 8 plus 5. This problem does have parentheses, and so we should start by adding 3 plus 5. Next, since there are no exponents, we can move on to multiplication and division. Since the negative 56 divided by 8 comes first as I read the problem from left to right, I will simplify that next. And now I can finish the multiplication and division step by noting that 2 times 8 is equal to 16. And finally, since negative 7 plus 16 is equal to 9, I can say that the final answer to this question is 9. Now, let's look at these two problems. Many students say that the answer to both of them is positive 625 because many students think that both of these problems are telling you to multiply negative 5 by itself 4 times. However, the order of operations says that, in the problem on the left, only the 5 is being raised to the 4th power. Depending on how you look at it, the negative sign in the problem on the left has to do with either multiplication or subtraction, and that means that we need to deal with it after we deal with the exponent. However, the problem on the right does tell us to multiply negative 5 by itself 4 times, and you should be able to see that the answer to this question is positive 625. To work this problem, we must, of course, start with the expression inside the parentheses. And since there is more than one operation inside the parentheses, we must follow the order of operations within the parentheses. This means that we should start by dividing 21 by 3. Next, we can say that 1 minus 7 is equal to negative 6. And now we can move on to exponents because the expression in the parentheses cannot be simplified any further. Note that negative 6 squared is equal to negative 6 times negative 6, or 36. And finally, since negative 3 times 36 is equal to negative 108, we can say that the answer to this question is negative 108. When a problem involves absolute values, you should always simplify any expressions within absolute value symbols first, and then take the absolute value. So, for instance, to talk about the absolute value of negative 2 plus 6, we must start by adding negative 2 plus 6, and then we can take the absolute value of the answer. And then, of course, we must continue following the order of operations to finish simplifying the problem. This example also shows how we must follow the order of operations when we are simplifying expressions involving absolute values. Note that, inside the second set of absolute value symbols, we did not start by subtracting 1 minus 4, because the order of operations says that, within a set of absolute value symbols, we need to multiply before we can add or subtract. If you have comments or questions about this video, please feel free to contact us using the Contact Us link on our website.